Hello everyone, I'm Shushmita Bijapur from Department of CSE AIML in BLDS CT College. Today I am presenting a topic from Theory of Computation under the unit Problems on Turing Machine. This video explains how to design a Turing machine to check for a substring using a DFA transition table and transition diagram. Problem on Turing machine. The question is obtain a TM to accept the language L is equals to W, where W belongs to any number of zeros or 1 containing the substring 001. In this problem, we are asked to design a Turing machine to accept binary string containing a particular substring. To solve such problems, we first construct a DFA to recognize the substring, then convert the DFA into a Turing machine. Now, the DFA which accepts the language consisting of strings zeros and ones having a substring 001 is shown as below. The first step in designing a Turing machine is to build a DFA for the same language. This DFA has the four states Q0, Q1, Q2, Q3, where Q0 is the starting state and Q3 is the final state or accepting state. This arrow shows how the machine moves between the state based on the input symbol. Now the transition from Q0 on the input symbol 1 it stays into the state Q0 because the pattern 001 cannot start with the 1. Next, on input symbol 0, it moves to the state Q1 because we may have matched the first 0 of the pattern. Now, the transition from Q1 on 0, it moves to the state Q2. Now, as we have seen, 00 is in the pattern. We have matched the first two characters of 001. On input 1, it goes back to the Q0 because 01 does not help us or it is not in the first pattern. Next, from transition from Q2. One transition from Q2 on input symbol 0, it stays in the Q2 or it is self-looped because if we see another 0, for example 00, the last two characters are still 00. If for the input 1, it moves to the state Q3 because we have found the substring 001 completely. Now the transition from Q3, this state loops forever because 001 has appeared. 001 has appeared even once. The string is valid no matter what comes next. This is the transition table for the DFA. Each row represents the states and column represent or shows what happens when we read input 0 or 1. In the state Q0, if the input symbol is 0, then it moves to the state Q1, and for the input symbol 1, it remains in the same state because it is self-looped. Then for the state Q1, if the input symbol is 0, it moves towards the Q2, and for the input symbol 1, it moves towards Q0 state. Then for the input symbol Q2, it's say for the state Q2, if the input symbol is 0, then it remains in the same state because it is self-looped, and if the input symbol is 1, it moves towards the state Q3. And for Q3 state, for both 0 and 1 input symbol, it stays in the same state because it is self-looped. This is the transition table for TM. A Turing machine transition table tells us what state the TM is currently in, what symbol it reads, what symbol it writes back, which direction the head moves, left or right, and what next state it will be. In our problem, the TM only moves right because we are simply scanning the string to detect the substring 001. Now from the transition from Q1, when the TM is in Q0 and sees the symbol 0, this may be the start of 001. So it write back 0 unchanged, moves right and goes to the state Q1. And for the input symbol 1, 1 cannot start 001. So the TM stays in the Q0 and keeps scanning. Now the transition from Q1 uh, sees another 0. Seeing another 0 means we have 0. So the TM moves to the Q2 and look for final 1. And for the input symbol 1, seeing 1 breaks the 0 pattern. So TM goes back to the Q0 to restart scanning. Next, for the transition from Q2, if we see another 0, the last two bits are still 0. So the TM stays in Q2 waiting for 1. So when the scanned input symbol is 1, then we have found the 001. So the TM goes to the Q3. In the state Q3, when it reads 0 and 1, it stays in the same state Q3 and writes back the respective 0 and 1 and moves right. Once the substring 001 is found, the machine stays in the Q3. For any further symbols, it keeps writing the same symbol and moves right. But when Q3 reads blank, the tape ends. The TM moves to the final accepting state Q4, write B's and moves right. This is where the machine halts. Next, in the state Q4, all the entries are blank because once the TM enters Q4, it halts and accepts the input string. This shows the transition diagram of the Turing machine that check whether the string contains the substring 001. Q0 is the start state. On reading 0, it goes to the Q1 state. On reading 1, it stays in Q0. Q1 means 10 is matched. On From the state Q1, on 0, it goes to this Q2. Now, two zeros are matched. On 1, it returns to the Q0 because the pattern breaks. Q2 means we have matched 2 0. Now on 1, from the state Q2 on 1, it moves to the state Q3. Now the substring 001 is found on 0. From the state Q2 on 0, it is self loop. It stays in the Q2 and continues checking. Q3 means 001 is detected or found on now in the Q3 state. For 0 or 1, it stays in the Q3. Then Q3 reads a blank at the end of the tape. It moved towards the Q4, the final accepting state. This diagram shows how the TM moves right along the tape and accepts only when it finds the substring 001. This is the formal 7-tuple definition of TM, where M is equals to Q comma summation comma delta comma tau comma Q0 comma A comma B, where Q is equals to finite set of states Q0, Q1, Q2, Q3, Q4. Summation is equals to 0 comma 1, which is the input alphabet. Then tau is the tape symbols, which are 0 comma 1 comma B. Delta is equals to, that is shown in the form of transition table. Q0 is equals to Q0, which is the start state. A is equals to Q4, which is the final state. B is equals to B, which is the blank character. Thank you all for watching the video and staying till the end.